Alright, so practice 1 for 6F. Rational applications. The speedboat can travel 32 miles per hour in still water. It travels 150 miles upstream against the current, then returns to starting location. So it's 150 miles both ways. So our distance is 150 miles. And the total time of the trip is 10 hours. And what is the speed of the current? So C is going to stand for speed of the current. And D is the distance. So D is distance. And we're going to look at, so if a boat, make fun of me all you want, here's your boat. If the boat goes upstream, so I have the little arrows here, this is the current that it's going from left to right on your screen. So the current is going left to right. So if I'm going upstream, the speed that you're going, the speed that the boat is going, the boat's going to work as if it's going 32 miles an hour, but it's not in still water anymore. It's going against the current. So if it's going against the current, we have to subtract off the speed of the current, and that's the speed of the boat. So S stands for speed of boat. And then going with the current's going to help you. So it's the speed of the boat. It's going to equal 32. That's how many miles per hour the speed the boat is going. And then the current is going to help that along. So it's going to help adding the speed of the current. Now, we also need, since we have the distance, which is 150, and we have speed, the only other thing we don't have is time. And the second part of the problem is talking about time. So that's where we're going to use distance equals speed times time, or velocity times time you could use. And since the second part of the problem is talking about the total time of the trip is 10 hours, we're going to talk about time. We want everything in reference to time, not in distance. So to do that, we're going to solve for t. So divide by s, divide by s. And the time equals the distance divided by the speed of the boat. So for each scenario, we need to go with the boat going upstream, and then downstream we need two different formulas. So upstream, so against the current, you have time equals the distance, which is 150 miles, and divided by the speed of the boat, so 32 minus c. Downstream, so that's with the current, we have the time it takes to go there is 150 over, and the speed of the boat is 32 plus c. So in math here, we have it's a transitive property. If t equals 150 over 32 minus c, and t equals 150 over 32 plus c, it must mean they're equal to each other. But in this case, we actually, let me back it up. It doesn't talk about equal time, so let's just cancel that. It is a possibility, but in this case, it says the total time of the trip is 10 hours. So the time it takes to go upstream and the time it takes to go downstream is totally 10 hours. So that means we need to add these times together. So if we're adding the upstream time to the downstream time, because this is the time downstream, the time it takes to go upstream, that has to equal 10 hours. And this is our equation we're going to use. So now I'm going to get like denominators. So I look at the denominators. What's common here? Nothing. So I'm going to take and multiply the first fraction by 32 plus c over 32 plus c. That way my denominator, my like denominator is going to be 32 plus c, 32 minus c. So my second fraction, multiply by 32 minus c over 32 minus c to get a 32 plus c times 32 minus c. And the last one is going to multiply by 32 minus c and 32 plus c. So I'm going to work out the problem now, and I'm going to actually pause it, work out the problem, and then you can see all the answer. Okay, so I did the math here. I'm going to explain it quick. So I had all like denominators, so I just dropped the denominators and solved the numerator. So that was the whole numerator up here. Distribute in the 150 on both. I multiplied 32 minus c times 32 plus c to get 1024 minus c squared. But then c, I have like terms, 4800 goes to 9600. 150c minus 150c, those cancel. And I distribute in the 10. And I subtract 10,240 over on the left side. The reason why I'm doing this, I do have a quadratic. You could use a quadratic formula, but since there's no b term, this is a c term when you put these together. There's a c term and there's an a term. If there's no b term, you can easily solve this. So you divide by negative 10, you get 64. C squared equals 64 square rooted. And you're going to get negative 8 and 8. But in this real world problem, going negative 8 miles an hour doesn't make sense. So 8 miles an hour. And you can always go back to the original, upstream and downstream, and put in 8 and see if it makes sense for the problem for time going upstream and downstream. So that is practice 2. Sorry, that was practice 1. This is practice 2. So read the problem quick and then we will get into it. So we have 2 people working here, Mr. Johnson and Everett. So Mr. J, it's going to take him X, let's say that's the rate that he is going to work to do. So the work completed he's going to complete 1 kitchen. For Everett, we'll just put him as E. He's got Mr. Johnson's rate plus 7 hours, and that's how much it'll take him to complete 1 kitchen. The general formula that I'm going to want you to know, it's very similar to the last problem. It's the amount of work being done equals the rate times time. So we have the rate here is x and x plus 7, and the work completed is 1 over 1. We don't know how much time it takes. So if you wanted x being, that's what we don't know. We don't know how much time it takes Mr. J to do 1 kitchen. And once we do, then we'll just add 7 and we'll know how long it takes Everett to do it. But in the second part of the problem, it also says we can look ahead and we say together they complete the same job in 12 hours. So together, we're going to take, and it's going to, the time is going to be 12 hours. So in 1 kitchen. So we have 12 hours total. So what I'm going to do is 12 hours, so it's time. So I'm going to divide by the rate to get it to be time, because the second part of the problem is talking about hours, time. So we want everything in time. So Mr. J, he's going to work. So we do work equals, or work divided by rate equals time. So the work is 1 over, so that's work completed, 1 kitchen, over the rate, x. And that equals time. In Everett's case, he's doing 1 kitchen, but he's got x plus 7, and that equals, that'll be equal to time. So the kitchen total together is going to be 1 kitchen, and it'll take them 12 hours to do this. that's the rate. So in 12 hours we can complete one kitchen, so the 12 hours for one kitchen. So that's why we have the rate there. So now we're going to work these numbers together. So together, we're going to, now I'm just looking at the left side or right side over here. So together it takes them 12 hours. So we're those three there. We have Mr. Johnson's time it takes. So everything's in time now. So Mr. Johnson's time plus Everett's time equals, if they work together, which that's why I added them here, because it's going to work together. It's going to be one kitchen, take 12 hours. So I'm going to pause this now. I'm going to solve this out and then explain. Okay, let's talk this out. So the red is the original. I looked at the denominators. You had x plus 7, and 12. There's nothing in common. You know, there's nothing to factor, so there's nothing in common already. So I just take the two denominators of the other terms and multiply by the first. So on this denominator is x, I needed x plus 7 and a 12 to get, that's going to be my common denominator, all those factors. My middle, I need a 12 and an x plus 7. And the last one, I already have 12, so I need an x and an x plus 7. So do that to numerator and denominator. Second step here, I started distributing. I did 12x times 12 times 7. So that's here. 1 times 12x is 12x. 1 times x is x, and then distribute it in. You get x squared plus 7x. You see a squared term. So I'm going to get all like terms together, and I move everything to one side. And then see I have x squared minus 17x minus 84. You can use the quadratic formula. You can factor these. I factored it, and I get x plus 4 equals 0 and x minus 21 equals 0. That's why you factors to solve. Solving each one, you get x equals -4 and x equals 21. Well, -4 doesn't make sense because you can't have -4 amount of hours. So the answer is 21 hours. So come to class with any questions you have. We'll talk about example 3 and probably work through some more problems similar to this. Also, don't forget about your quiz. Thank you. All right, quiz on 6D and 6E.